First one is ozone layer depletion. Okay. Recently, satellite measurements over Antarctica have detected a giant ozone hole in the ozone layer. Okay. The hole, which scientists called as a ozone depleted area, was 26 million square kilometer in size, roughly 3 times the size of Brazil. That is a huge one. Okay. So ozone means O3, you know, right? Ozone is O3. Means three oxygen molecules are combined to form the ozone. Okay. So in Antarctica, there is a huge hole on the ozone layer. Ozone is seen in which layer? No. Stratosphere. Stratosphere. If ozone is seen in the troposphere, means that is bad ozone. Okay, we have bad and good ozone. Good ozone means what we require or what we need, and it is in the stratosphere layer. Why? What is the need of ozone? Protecting from UV sun rays. Okay, UV rays. That is the most important aspect or function of ozone layer. When it is in the stratosphere, it is acts as a protection layer, and that is why we have good ozone in the stratosphere layer. Below that, we have troposphere layer. Troposphere layer is the first layer which is closer to the Earth's surface, and above that is the stratosphere. Okay, what is the width of troposphere layer? 8 to 18 kilometers is the width of the troposphere layer, and above that is the stratosphere layer. Okay, and above 18 kilometer is the 8 into 18 in the poles and equator approximately. Okay, above that is the stratosphere, and in the stratosphere we have the good ozone, or which is the layer which is absorbs the UV rays, harmful rays, especially UVB rays. UV rays can be UVA, UVB, and UVC. Okay, UVB rays are usually absorbed in the by the ozone layer, because these are the rays which cause skin cancer or melanin pigmentation increases in the human beings or animals. Okay, living organisms. So this layer is responsible for absorbing that. When it is in the troposphere layer, means that is bad ozone, because these react with pollutants like other gases and other pollutants and forms photochemical smoke. Okay, which is harmful for human as well. In case of respiratory eye diseases, it causes. Okay, so photochemical smoke is the layer which is formed when ozone is in the lower layer, troposphere. When it interacts with pollution, it forms photochemical smoke. That is why ozone in the troposphere layer is usually considered bad ozone. Clear? Okay. So now here there is a ozone hole which appeared above the Antarctica layer. Why is it appeared? Is because of the before that, European Space Agency. It was discovered by the European Space Agency's Copernicus Sentinel 5P satellite, measured trace gases in the atmosphere in order to monitor ozone and climate. And it showed that this year's ozone hole started earlier than usual and had a big extension. Every year there will be a decrease, or there is an instance of ozone hole. But this year it started earlier. Okay. The size of the ozone hole over Antarctica fluctuates each year, opening each year in August and closing again in November or December is usually happening. Usually every year there will be ozone hole formation. But this year it started earlier, as well as the extent of ozone hole is also bigger. This is due to volcanic eruptions at Hunga Tongan, Tonga. Okay, this is a volcanic eruption that happened in December 2022 and January 2023. That is the reason why it occurred earlier. These eruptions were so violent that the water vapor got extended even into the stratosphere layer. Okay, water vapor into the stratosphere layer means increase in temperature in the stratosphere layer. Also, the water vapor, the gases from the volcano contain chlorine and bromine, etc. Okay, These reacted with the ozone molecules, oxygen from the ozone molecules, which further decreased the ozone layer. Clear? This is a volcano, and we have troposphere and stratosphere. The volcanic eruptions were so violent that water vapor. Major content of the volcanic eruptions are water vapor. Nearly 70% is water vapor. Okay. Along with other gases. So water vapor straight into the stratosphere where ozone layer is present. Okay. This in turn caused the increase in the temperature of the layer, and also there were other gases like which contain chlorine, bromine, etc. These chlorine, etc. reacted with oxygen molecule. This cut the ozone and reacted with this to disruption, leading to disruption in the ozone layer. Clear? Okay. This is how ozone holes are formed every year. Okay, but this year it got very high and also earlier. Okay, so ozone layer. We studied this, right? Ozone layer is a region of high ozone concentration in the stratosphere, 15 to 35 kilometers above the Earth's surface. The ozone layer acts as an invisible shield and protects the Earth from harmful UV radiations from the sun. In particular, ozone layer protects the Earth from UV radiation known as UVB. We have three types of UV: UVA, B, and C. B is the one which causes sunburn and it is protected by UV. Okay, in the stratosphere layer. Now, long-term exposure to high levels of UVB threatens human health and damages most animals, plants, and microbes. So, ozone layer protects all life on Earth. How does ozone layer protects from UV? Ozone absorbs UV. It absorbs. The process is absorbs. Okay, UVB radiation from the sun. When an ozone molecule absorbs UVB radiation, it comes apart into oxygen molecule and a separate oxygen atom. Later, the oxygen component can preform the ozone molecule and O3 is formed again. Clear? I think I have a picture. Okay, no. See, initially ozone is there. What it does is it absorbs UVB and it again forms oxygen plus oxygen atom plus a molecule. Okay. Then since it doesn't have any other pollutant in it, if it doesn't have any pollutant in it, it again rejoins to form O3. This is the naturally occurring process. But ozone hole is occurring because here pollutants like chlorine, bromine, etc. occurs. So what it forms, it joins with these individual atoms. Okay, so oxygen remains plus ClO, etc. Clear? We'll see with this, a picture is there. I'll show you. Okay. Man-made chemicals containing. Okay. Why I wrote chlorine, bromine, etc. Because halogens are the important pollutants which is responsible for reduction of ozone layer. They are the ones which react with the oxygen molecule. Okay. Man-made chemicals containing halogens. Halogens like halogens example. Halogens, periodic table. Chlorine, bromine, etc. Okay, fluorine is also a halogen, but fluorine is not included in the depletion of ozone layer. Most important part. Halogens containing chlorine, bromine, etc. are majorly involved in the reduction of ozone layers. Clear? Were determined to be the main cause of ozone loss. These chemicals are collectively known as ozone depleting substances. The most important ozone depleting substances were chlorofluorocarbons, CFCs. Heard of this? Where? These are usually used in the refrigerants. Okay, so that is the reason why later we have certain conventions and protocols, etc. Okay, according to that, these was not the CFCs should be reduced, and later it was replaced by HFCs, hydrofluorocarbons. Why fluorocarbons? As I said, fluorides are not responsible for reduction of ozone layer. Since there was a misconception, or there is a misconception, that fluoride causes decrease in ozone layer since it's a halogen, but it is not like that. Fluorides are not reducing ozone layer. Okay, other halogens like chlorine and bromine are responsible for reduction in ozone layer. Okay, so most important ozone depleting substances were chlorofluorocarbons, or CFCs, which one time were widely used in air conditioners, refrigerators, aerosol cans, and in inhalers. Clear? Okay, this is the picture. Normally, what is happening is we have UVA, B, and C layer. Okay, ozone acts as a shield layer and it absorbs UVB. And normally, what happens? Ozone layer there, it absorbs UVB and it divides into oxygen molecule and an atom, and later it get again converted into O3. This is a normal procedure when no pollutants are there. But due to CFCs, what happened is like this one is the ozone molecule. Okay, when it absorbed light, it got converted or it got split into this one. Then this chlorine atom got involved, or bromine atom were there, and they took away this single oxygen atom. Okay, so only oxygen molecule plus ClO or BRO, etc. were present. Clear? So no oxygen ozone formation is happening. Clear? Ultraviolet rays split a chlorine atom from CFCs, chlorofluorocarbons. Ultraviolet rays are also responsible for splitting of CFCs as well. CFC means chlorofluorocarbons. In that, chlorine atom is there, right? This chlorine atom will join with the oxygen molecule. The chlorine atom breaks up ozone molecule, making a hole in the ozone layer. The molecules left behind are chlorine monoxide and oxygen. Clear? Chlorine monoxide and oxygen. Clear with this? Okay. That is why when pollutants like CFCs, etc. are there, there is no reformation of ozone is there. Because the oxygen atom, single oxygen atom will be taken up by these halogens. Clear? You will be studying this in once more in pollution environment as well. Okay. Now, what are the effects of ozone depletion? First one is effect on human. Ozone layer depletion increases the amount of UVB that reaches the Earth's surface. What is the effect of UVB? It causes skin cancer, development of cataracts, clouding of eye lenses, etc. Clear? Now, what are the effects on plants? That is, it causes physiological and developmental anomalies in plants. Despite mechanisms to reduce or repair these effects and an ability to adapt to increased level of UV, plant growth can be directly affected by UV radiation. There is an increase in temperature or increase in UV radiation, right? So normal physiology of the plant will also be hindered. Okay. So in human, there will be skin cancer and other conditions like cloudiness of eye, cataract, etc. And in plants also, there is a physiological variations of normal physiological cycling in the plants as well. Now, other effects in marine ecosystem. Okay. Phytoplanktons. What are phytoplanktons? In the marine ecosystem, in the sea. Similarly, plants are the producers in earth or land area, right? Similarly, phytoplanktons are the producers. They absorb sunlight and are able to produce their own food. Okay, so they are the producers in the water. Okay, phytoplankton productivity is limited to the euphotic zone. Euphotic zone is meaning upper layer. Okay, where the photosensitivity or the light is getting. The upper layer of the water column in which there is sufficient sunlight to support net productivity. This is usually what happening. Okay. See, this is water, and here phytoplanktons could be seen. Okay, so here in the upper surface only the light will be there, right? So phytoplanktons are confined to that area only, and in that area they are responsible. They are able to produce their food. Okay. Exposure to solar UV radiation has been shown to affect both orientation and mobility in phytoplankton, resulting in reduced survival rate of these organisms. Similar to what happening in plants, like their physiology is affected. Similar to that, they are phytoplanktons are also producers, but difference is they are in plants are in lands and phytoplanktons are in water. Similarly, their physiology, like orientation and mobility, are also getting affected. Okay, scientists have demonstrated a direct reduction in phytoplankton production due to ozone depletion related increases in UVB. Okay, UV radiation has found to cause damage to early developmental stages of fishes, shrimp, crab, amphibians, and other marine animals. Marine animals' development is also hindered due to ozone depletion or ozone hole in ozone layer. Next one is effect on biogeochemical cycles. You have heard about carbon cycle, phosphorus cycle, etc. Like cycles of gases, how they are produced, nitrogen cycle, etc. Right? So biogeochemical cycles are also getting affected. These biogeochemical cycles are required for life or for sustaining life on Earth. Right? Increase in UVB radiation could affect the terrestrial and aquatic biogeochemical cycles, thus altering both sources and sink of greenhouse gas of chemicals, importantly trace gases. Sources and sink means, for example, carbon dioxide. Carbon are usually produced from fossil fuel burning, etc. Right? So they are the sources of carbon. Okay, what is a sink? Sink means absorb. Forest is a carbon sink. Okay, so these both are altered. Forest means plants. Plants biochemical physiological cycle is also getting hindered, so their rhythm is also getting affected. So both the sources and the sink are getting affected by the change in ozone layer. Why? Because the carbon cycle is getting affected, if we say in case of carbon. Okay, so biogeochemical cycle is getting affected. That means the sources and sink of the gases are is also getting affected. Okay, increase in UVB radiation could affect the terrestrial and aquatic biogeochemical cycles, thus altering both sources and sink of greenhouse and chemically important trace gases. Example: carbon dioxide, carbon monoxide, carbonyl sulfide, ozone, and other possible gases. These potential changes would contribute to biosphere and atmosphere feedback that mitigate or amplify the atmospheric concentrations of these gases. What is biosphere? Life, in which life is present, a sphere in which life is present. Okay, that includes both the life, living organism, and its adjacent environment, abiotic and biotic environment of a area, okay, where life is present. So biosphere and atmospheric interaction. Atmosphere, see, if we have methane or wetlands and the important sources of methane, you know, right? So wetlands means they are areas in earth, they produce methane, okay, to the atmosphere, right? This are getting sinked into oceans or absorbed by oceans or forest, right? So that again land. So atmosphere and biosphere interactions. When there is a change in the level of gases, the normal interactions would also be hindered, right? So there is a change in the atmosphere biosphere interaction as well. Clear? Okay. Sorry. Okay. So these are certain effects of ozone layer depletion. First is effect in human beings. Human beings effects includes our skin diseases like skin cancer, cataract, and cloudiness. Next in plants. In plants, it comes into normal biological cycle or physiological cycle of the plant gets affected. The same with the marine ecosystem. Even the plants are primary producers of the including phytoplanktons getting affected, and also in the early development stages of shrimps, fishes, etc., getting marine ecosystem, marine animals is getting also affected. Next is regarding the biogeochemical cycle. The source and sink of the biogeochemical cycle alteration gets getting differed. And best example we took is regarding the carbon. Okay, carbon sources like example wetlands, etc. Wetland livestock, etc., are important sources of methane. Okay, they are released into the atmosphere, and from that carbon sink are oceans, forest, etc. Okay, there will be a disruption in the source and sink. Okay, so there will be a disruption in the biosphere atmosphere feedback mechanism as well. Okay, now, so since these are the effects of, there are many effects to every part of the world, like every part of the earth. So there are mechanisms or there are discussions for reduction of the ozone depleting substances. What are the ozone depleting substances? Majorly halogens, including CFCs, etc. Okay, so there was a talk between the countries to reduce it, and consequently, they developed Vienna Convention. Vienna Convention for Protection of Ozone Layer. Okay, formalized in the Vienna Convention for Protection of the Ozone Layer, which was adopted and signed by 28 countries on March 22nd, 1985. Okay, in 1985, Vienna Convention happened. Convention was accepted and signed by 28 countries for the protection of ozone layer. And in 1987, this led to a drafting of the Montreal Protocol on substances that deplete the ozone layer. There was a convention on Vienna, a convention for depletion of to tackle the ozone layer depletion. That is Vienna Convention, and it was in 1985. Under that, a protocol was drafted, Montreal Protocol on substances that deplete the ozone layer. It was on 1987. Clear? 1985 Vienna Convention, and under that 1987 Montreal Protocol to reduce substances that led to the ozone depletion. Okay. Now, Montreal Protocol. What is Montreal Protocol? It is to protect the ozone layer by taking measures to control the total global production and consumption of substances that deplete it. What is the major important substance? CFC. Clear? In 1994, United Nations General Assembly proclaimed 16 September as International Day for the Preservation of Ozone Layer. Okay. In 1987, the Montreal Protocol came, and it was to reduce the substances which causes depletion of ozone or ozone depletion substance, especially CFCs. So CFCs were used for in aerosols, inhalers, refrigerants, etc. Okay, so we need an alternative. So for that, we developed or we used HFCs, hydrofluorocarbons. Does this cause ozone depletion? No. But there was another problem. That is, this caused global warming. This was a higher global warming potential gas. Okay. So we wanted to decrease ozone depletion by controlling the ozone depleting substance of CFC, chlorofluorocarbons. For that, we introduced, in place of CFCs, we could use HFCs. Okay, but HFC's problem of HFC was it led to increase in global warming. So to control HFC, to control HFC, there was an amendment called Kigali Amendment. Kigali, to control the level of HFC. Why? Because they are increasing the global warming. Clear? Okay. So is Kigali Amendment for ozone depletion? Is Kigali Amendment for ozone depletion? No. This is for reducing the level of HFC. Clear? Now, India's achievement. India is a party to Montreal Protocol since 1992. When did Montreal Protocol came into force? 1987. India became the member in 1992. has been successfully implementing the Montreal Protocol and its ozone depleting substance phase out projects and activities in line with the phase out schedule of the protocol. India has phased out CFCs, chlorofluorocarbons, carbon tetrachloride, halons, methyl bromide, and methyl chloroform for controlled uses in line with Montreal Protocol. Okay. India has almost achieved that. It could control only in necessary cases the CFCs or carbon tetrachloride, etc. were used. Okay. India is in accordance with the Montreal Protocol. Now, in 2022, India officially ratified the Kigali Amendment of the Montreal Protocol, joining 125 other countries in the fight to phase out HFCs. To phase out HFCs, Kigali Amendment was introduced from the Montreal Protocol as a part of Montreal Protocol, right? So, along with the 125 countries, India officially ratified the Kigali Amendment in 2022. Recently. Okay. Another India's plan to reduce the ozone depletion is in 2019, India Cooling Action Plan, ICAP, is launched by Ozone Cell of Union Ministry of Environment, Forest and Climate Change. ICAP, India Cooling Action Plan. ICAP aims to provide sustainable cooling while keeping in mind at the same time the need to protect the ozone layer. So, these were the India's achievement. One is India joined the Montreal Protocol in 1992 and India has achieved a reduction in the CFCs, right? Now, in 2022, India has officially ratified the Kigali Amendment, which was for the reduction in HFCs, hydrofluorocarbons. And also in 2019, India Cooling Action Program by India's Environment MOEFCC is also taken place, launched, okay, by the Ozone Cell for sustainable cooling and as well as to protect the ozone layer. Clear? Then what is the way forward? First one is ensuring that existing restrictions on ozone depleting substances are properly implemented and global use of ozone depleting substances continue to be reduced. Proper implementation. It is not that like by creating or launching a amendment or protocol we can reduce it. So implementation is the most important key, right? So by properly implementing and by global use of reduction of substances of global ozone depleting substances could increase the could be a way forward. Okay. Next one is ensuring the banks of ozone depleting substances, both in storage and contained in existing equipments, are dealt with an environmentally friendly manner and are replaced with climate friendly alternatives. This means that usually CFCs, stored CFCs are leaking. Okay, leakage happens in these plants, and this will further lead to depletion in ozone layer. Okay, so while storing these things, we can, if we have more caution, then the leakage incidences could be reduced. Okay, so by ensuring that the storage areas could be properly monitored and also gradually we can have an environmentally altered substances for this could be developed. Okay, so this could be another way forward for this. And ensuring that permitted uses of ozone depleting substances are not diverted to illegal uses. See, as we know that refrigerants, etc., are using CFC, so we can't fully rule out the presence of this in from the world. Okay, there is a permitted amount of usage of this gases. Okay, so we should confirm that only the permitted amount are used and illegal uses are stopped. Okay. Next one is reducing use of ozone depleting substances in applications that are not considered as consumption under Montreal Protocol. Okay, that is, as I said before, Montreal Protocol allows certain amount usage of these substances. Okay, so if we could reduce that also, then our ozone depletion could be reduced to a greater extent as well. Okay. Reducing use of ozone depleting substances in applications that are not considered as the consumption under Montreal Protocol. Ensuring that no new chemicals or technologies emerge that could pose new threat to the ozone layer. Okay. Very short-living substances are often responsible, like halogens, chlorine, bromine, etc., are often responsible for reduction in ozone layer. Okay. So if at all we are developing new substances, we should take utmost care that these are substances that are not short-lived. That is, they are not will not cause any depletion in the ozone layer. Clear? Okay. So ozone layer depletion. What can be the way forward? First is implementing. Proper implementation of the protocol should be done. Second is, if at all we are storing this, then we should have a proper care to avoid leakage. And if we are developing new substances, we should take utmost care that these are not ozone reducing substances. That is, they are not short-lived substances. Next one is, yes, reducing use of ozone depleting substances even when they are not, even if they are not not prescribed under the Montreal Protocol. Okay. And if we are using this, we should prevent it from any illegal uses. Okay. These are some of the way forwards by which we could reduce the ozone depletion.